Hello, everyone. My name is Dr. Sue Paul. I'm the Senior Director of Wellbeing and Brain Health for Asbury Communities. Welcome to this month's episode of Ask Asbury. March is Brain Health Awareness Month. And today I am joined by Dr. Michael Yassa, a neuroscientist at the University of California, Irvine, who studies how memory works in the brain and what happens as it changes with aging and Alzheimer's disease. He directs the Center for the Neurobiology of Learning and Memory and has helped develop some of the tools that researchers use to detect memory changes early. Dr. Yassa, thank you so much for being here today.
Thank you for having me.
This is great. So let's just get started with kind of a high level question. Give me a recap of what the biology of Alzheimer's really is.
So the biology of Alzheimer's, if we go back historically, the initial biology that was first identified by Dr. Alois Alzheimer himself, when he looked under the microscope at the first evidence of pathology in the brain, were the things that we refer to now as plaques and tangles. It was essentially forms of protein that looked off, looked strange, looked weirdly clumped together in a way that they shouldn't be. And we came to realize very quickly that these proteins exist in the brain, in all of our brains, and they serve important functions. But due to some circumstances that can happen in the Alzheimer's brain in the early stages, they change. They change their structure. They change the way that they bind together, connect together. They change the way they fold, and some of those changes can be what we call pathological.
Hmm.
And that was the first observation, is these clumps of protein that seemed disordered, seemed problematic. But as time went on, we started to discover much more about the biology of Alzheimer's, that it's not just protein. There's a lot of other things that are happening. First, there's massive cell loss that happens in the brain. So brain cells, normally in the healthy aging brain, don't really degenerate. They don't die. It's not like skin cells that die off and you replace them with new ones. Our brain cells tend to be very long-lived if they're left to their own devices. They change their function. They might slow down a little bit in terms of their communication over time. But in the Alzheimer's brain, they actually die, and they die progressively. And this is why we call it a progressive neurodegenerative condition. And that's where the degenerative comes from. So that became an important realization. The size of the brain shrinks massively. A brain with severe Alzheimer's disease looks to be about a third of the size of a healthy brain in extreme circumstances. So it is a massive cell loss event. But the most interesting discoveries about the biology of Alzheimer's disease, I would say, have happened in the last couple of decades, where we've come to understand better that there's also inflammation that happens in the brain. So that's the brain's immune response kind of gone awry. Normally, the immune response helps protect us from pathogens, from infections, but in the Alzheimer's disease, it's just put in hyper mode and it becomes itself pathological. We know there's also vascular changes. So our blood supply is really important from our heart to our brain, and the brain actually contains the largest blood supply of any other organ in the body. And that blood supply turns out to be vulnerable to Alzheimer's disease. So even small changes from heart disease, from stroke, from diabetes, from any sort of risk factors for heart disease will impact brain health and can predispose individuals to a higher risk of Alzheimer's disease. So those are generally the kinds of things that we think about in terms of the biology. There's one other aspect that I would add, which is that there seems to be a genetic component, although it is not very well understood in the version of Alzheimer's that is most common, what we call sporadic Alzheimer's disease, as opposed to a much more genetic form of Alzheimer's disease that happens very early on, but it's much more rare. So that genetic basis, you may have heard about it. People talk about the ApoE gene, apolipoprotein E, and whether you have the ApoE4 gene versus not increases your risk for Alzheimer's disease, but it's not deterministic. So just having that gene does not mean you're going to get Alzheimer's, and not having the gene does not mean you're not going to get Alzheimer's. It just increases your risk. But then again, that many things increase your risk. And how that gene increases risk is by changing the way that those proteins are folding, how those proteins are produced and cleared in the brain. So that may be a little bit more than, Then you were
Well,
looking for,
it's
but that's sort of the thumbnail sketch of the biology.
that's great. It is more about than just plaques and tangles, which has been sort of the song of Alzheimer's for a long time. So that's helpful to know. But let me ask you, if we could detect Alzheimer's, 20 years before symptoms appear, and I think this is sort of your wheelhouse, are we actually ready for that? Like psychologically and ethically, are we ready to take action or to know that sort of information ahead of time?
So my answer might surprise you. I would say it's a strong yes. And for a couple of reasons. One is that I believe that we are much more powerful as individuals, as groups, as families, as communities when we're informed. And being informed about our condition many, many years earlier allows us to take steps to prevent or to change the trajectory and
Mhm.
the progression of it. If there was an ethical discussion about this probably 10, 15 years ago, where people said, well, if I find out and there's no treatment, are you just like compromising me psychologically? And unfortunately, we heard that a lot more from clinicians than we heard from patients and families. Patients and families wanted to know. So it really does come from a position of knowledge is power. But the good news is now we know there are things we can do about it. So when we do discover that there's increased risk early on, or there's evidence of pre-Alzheimer's, maybe aggregation of protein, now we can pick up on some of these pathologies with brain imaging while the person is still alive. We don't have to wait until the person passes to look under the microscope. So with the new technology, we can detect things earlier. And with new understanding of the biology, we also have potentially promising therapeutic treatments. They're not perfect. They're not where we want them to be. I wish we had made more progress, but they're paving the path towards what will become more and more effective therapeutics.
Good.
That's on the pharmacological side, but there are things we can do even without the pharmacology in terms of protecting ourselves. And you know about this all too well, Sue, right?
Hmm.
Exercise, mental health, reducing stress, all of those things actually stave off risk for Alzheimer's disease. And I was very heartened to see the results of a comprehensive clinical trial that was released just last year called the Pointer Trial, which is a comprehensive lifestyle intervention that includes exercise, meditation, diet, all of those things, but no pharmacological treatment,
Hmm.
no drugs. And they showed that actually you can stave off risk for Alzheimer's disease. So that to me is much more evidence in favor of finding out as early as possible, and then taking active steps to do something about it.
That's wonderful. Do you think that there one of those lifestyle factors that stands out to you, like the one or two that we should really aggressively, work on?
Yes, so I'm a huge fan of the physical activity data for a
Hmm.
couple of reasons. One is that you see evidence of it epidemiologically. Individuals who are more fit into middle adulthood and older age tend to be at reduced risk for Alzheimer's disease. Two, you also see it in clinical trials when you randomize people to an exercise intervention versus a control intervention. You see results of that. And then maybe the third piece, which is a little bit more indirect, is that higher levels of physical activity and physical fitness tend to have indirect effects also. So they improve vascular flow, they improve inflammation, they improve stress, they improve a number of other things which we know are risk factors for Alzheimer's disease. So there's direct and indirect effects. I joke sometimes, I say it's like it's just it literally is the magic bullet. It has all positive effects.
Yeah.
The only exception is injury, of course. So we have to be careful when things get a little bit too much, especially into older age. We worry about frailty. So they have to be safe exercises and really work to reduce the risk of injury.
Hmm. That's my favorite one too, of all of them.
I figured as much. Yeah.
All right. Well, let me ask you about some of your research. Are we close to having a blood pressure cuff for for the brain? And similar how we can detect issues with heart disease?
Yeah, that is a fantastic question. It is literally the billion-dollar question. I think we're a lot closer, and I'll tell you where I think it's going to come from. So it's interesting you bring up the blood pressure cuff. It's my favorite example. I bring it up all the time because it's a fantastic biomarker. And what I
Hmm.
mean by that term is that it's a measurement of something that's happening inside the body that tells you about your risk for disease. And we're interested in measuring blood pressure because, like you said, it tells us something about your risk for heart disease. So by the same token, a measurement of some sort of a biomarker should help us understand our risk and maybe how lifestyle factors and things like that are changing our risk for Alzheimer's disease. There's two areas, actually three areas in which I think there's interesting potential candidates. One is fluid biomarkers, blood-based biomarkers, and more recently we've done work on salivary biomarkers that are a lot easier to kind of collect because it's just a saliva sample rather than getting a blood draw. But there's been a lot of advances in terms of being able to measure proteins that live in very small concentrations in the blood, but are highly correlated with what's happening in the brain. So they act as a biomarker, just like the blood pressure cuff. They tell us about changes that are happening in the brain and the dynamics thereof. That's a
Hmm.
really rapidly improving and rapidly moving area of research. The second one is measuring physiology. So, everybody's got an Apple Watch or a Garmin or an Oura Ring or any of those things. Well, these provide some really comprehensive measurements of things like heart rate variability, of changes in your sleep-wake cycle, changes in your physical activity levels. Those indirectly can be good proxies also for what's happening. More work needs to be done on that front to really make biomarkers out of them, but the technology is moving at such a breakneck speed that it really will lead to some nice insights very, very soon. And again, there's some potential candidates there, particularly in the sleep area, being able to measure
Hmm.
aspects of sleep and how it's changing. And then the third piece, which I'm very excited about, is what we call digital cognitive assessments. And these are cognitive assessments that are kind of like little brain games that you play, but they're not intended to train you and make you better. They're trying to assess your memory and cognitive abilities and your thinking abilities. And we can do that on an app, we can do it on a phone, on a computer, on whatever. And being able to do that with some frequency allows you to maybe monitor your brain health or your cognitive health. And I think from there, we'll be able to develop, again, digital cognitive biomarkers that would allow us also to say something about the disease. So, three areas that are moving very rapidly. There's a lot of progress still on imaging, brain imaging approaches, but they're not scalable. Like you have to go to the hospital to get an MRI or a PET scan. So I'm thinking about this from the can I do it from home perspective,
Right.
right? That's really what the focus is.
Yeah, feasibility.
Exactly,
That
exactly.
definitely
And
matters.
accessibility, you want to make it accessible to as many people as possible, right?
Are you hopeful that we will actually be able to prevent Alzheimer's, or will we have to like learn to live with it like we do with heart disease?
What a fantastic question. I don't think it's either or. So I think that in some cases, it will be about management.
Hmm.
And it will be about considering it a chronic condition. And the question is just to extend quality of life as long as possible or push the age of onset or delay the progression so that, eventually, actually, people will pass from other health conditions and not Alzheimer's disease itself.
Hmm.
So management as a chronic condition is another big area that people are trying to do right now. And with physical activity and things like that, that's likely going to lead to some real management strategies. The notion of prevention is a tricky one because the question is how early do you prevent?
Hmm.
And the story
You
with
could argue a lifetime.
exactly. And
Yeah.
actually, that's been the story with the anti-amyloid therapeutics when they don't
Hmm.
work. The argument from colleagues in the field has always been, well, we're not intervening early enough. So then you go earlier and then it doesn't work. And you go, we're not intervening early enough. And I sometimes will joke with them and say, how early do we need to go? Like, do we go into the womb? Like, how early are we really talking
Right.
here? Um, but it is a valid question. I mean, we do have vaccinations and things that do protect us from various infections and various
Mhm.
conditions that have been eradicated largely because of vaccination. So there was an attempt to create anti-Alzheimer's vaccines a while ago, but it ended quite badly, and then people never went back to it. Now there's rejuvenated interest in the idea of kind of a primary prevention.
Mhm.
Um, but absent that, secondary prevention is a possibility, which is that you give an agent, pharmacological agent, at a very early stage in the disease, and you actually prevent the onset of the pathological condition. So maybe clearing amyloid before it aggregates, or clearing or changing I don't want to get too technical, but like the phosphorylation of tau before it becomes tangles, that kind of thing. Uh,
Mhm.
and I think there's a lot of promise in those areas as well.
Yeah.
But the clinical trials just take a long time because
Right.
prevention, you need to wait until people are actually declining, right? So the logistics of
Right.
those kinds of trials are very tricky.
Yeah, those upstream interventions are kind of hard
Yep,
to prove. I mean, like you said, you have to wait to see if they work, but
that's right. That's right.
yeah. Um, Let me ask you this. What gives you genuine hope right now and optimism? Is there anything going on that it's not hype, but it's actual real hope?
Um, yeah, I mean, I became very optimistic, and I recall a moment at the Alzheimer's International Conference where the results of the Pointer trial were announced by the investigators. And I think we all got up and started clapping. We gave them a standing ovation because we were just so relieved to hear that
Hmm.
something that is, it's not that it's simple or straightforward, but it's something that anyone can do
Hmm.
worked. And we wanted more, and we wanted to understand the dynamics, and they did such a great job also in terms of diversity of recruitment and all of that. So that it's the kind of approach that actually might work for a lot of people and not just the select few. So that gave me a lot of hope in terms of prevention and kind of owning it, right? And taking control and seeing that modifiable lifestyle factors, if put together, in a meaningful way, they can actually protect people to a
Hmm.
large degree from something like Alzheimer's disease. But on the flip side, I'm also seeing that, I have many issues with the regulatory approval process. And I think that, our FDA process is not perfect. It's what we've got, but it's not perfect. And we certainly need a regulatory approval process. But there's been a couple of questionable approvals, one would say, based on data that were not of the greatest quality. But the fact that there have been approvals has rejuvenated interest in the pharma and biotech world to develop more therapies, to develop more drugs, after a period of time where they had decided to stop investing. There was a period where they decided this is just too difficult, too hard. We don't want to do this anymore because things keep failing, and we can't even justify it to investors anymore. But having the approvals and the potential of these drugs to really make a difference, even though the current drugs that are approved are not great, I am hopeful that the next generation of drugs will be better and better and better. And now there's a path
Hmm.
to get those approvals.
Hmm.
So that also gives me some optimism, although it's a little bit more of a long game.
Well, that ties very well into my last question for you, which is like the 50-year retrospective view. What do you think will be like, wow, we just missed that. It's like right in front of our face. And how did we miss that?
So I'll share with you my latest thinking on this. And keep in mind, it wasn't always my thinking on this. I think when I started studying Alzheimer's disease decades ago, it was simplistic. We thought in terms of plaques and tangles, and then we started to add more features, the vascular, the immune, all of those things. And we kept calling them co-pathologies, comorbidities, co-everything. And I think that what I'm coming around to really understanding is that Alzheimer's disease has been treated for a long time as a single disease. And in reality, it's much more likely to be a collection of diseases disguised and kind of hiding under the same umbrella. And the complexity of Alzheimer's disease is such that that collection means we need to understand everybody's control points. That's a technical term, but it refers to my version of Alzheimer's, if I get it, will likely be different from your version if you get it. Mine may be immune in nature. Yours may be vascular in nature. Somebody else's may be more metabolic in nature. And even though they all funnel into the same outcome, the upstream, like you said, the upstream mechanisms could be wildly different, which means if we're trying to just target one drug for everyone, focusing on a single upstream mechanism, we're necessarily only going to help a subset of people. And if you're doing a clinical trial, a subset of people ain't going to get you significance, right? So you're not going to get a trial that actually works unless you break up the population you're testing into groups, what we call stratification. So the argument that I've been making to many colleagues in the field and pharma colleagues as well is that we need to do much smarter clinical trials and we need to develop drugs in a very different way so that we're tackling the complexity of Alzheimer's diseases and really think about it as a collection of different conditions that need to be managed or treated in different ways. That's a lot closer to a precision medicine approach. It's been applied to cancer with wild success. So I would argue that we need to take the cancer playbook and really apply it to neuro conditions, in particular Alzheimer's disease. But I get into this conflict with my colleagues in the field because many of them feel like, we still want the one-shot answer. Pharma companies certainly want the one drug to cure them all, right? There's big financial incentives for that. So I think it'll take a little while. And I'm glad you said in 50 years, because I think in 10 it may not happen, but in 50
Hmm.
we'll look back and say, how was this
How do we
not
miss that?
obvious to us? How did we
Mhm.
miss the fact that this is just a bunch of different conditions that need to be treated differently? So anyway, that's
I
my opinion on
absolutely
this.
love that idea because it just makes sense. I can just visualize like exactly what you're saying as being a reasonable assumption to make,
Yeah.
when you're in the dark, basically trying to find your way out. But it does sound very logical. So
Uh,
I'm going
Thank
to
you.
say I knew you win.
I feel like it's very logical as well, and I hope that it will start to take hold in the field, and that we'll start to get to embrace the complexity of Alzheimer's disease as
Right,
opposed to kind of running away from it.
right.
So
Well, Dr. So thank you so much. This has been so exciting talking to you. This is one of my favorite topics to talk about, obviously. And I've been a big fan of yours for many years.
likewise,
So
Dr. Paul,
thank you so much
thank
for
you so
being on
much.
today. Have a great day.
Appreciate it. You too. Thank you.
Thanks.